Conversion of galvanometer to ammeter. The galvanometer is an instrument used for detecting electric current. A galvanometer can be converted into an ammeter for measuring larger current by connecting a low resistance called shunt resistance in parallel to the galvanometer. Theory: let G be the resistance of the galvanometer and Ig be the current for full-scale deflection in the galvanometer. The value of the shunt resistance S required to convert the galvanometer into an ammeter to measure a current of I ampere is S is equal to Ig into G divided by I minus Ig. Let L be the length of the resistance wire required for a resistance of S ohm. Then L is equal to pi r square S divided by rho, where r is the radius of the wire and rho is the resistivity of the material of the wire. Here, we are converting the given galvanometer of known resistance or figure of merit into an ammeter of desired range. Materials required: galvanometer, cell, rheostat, ammeter of desired range, resistance wire, key, screw gauge. Procedure: the shunt resistance required to convert the galvanometer into ammeter of range I is calculated using the formula S is equal to Ig into G divided by I minus Ig. G is the resistance of the galvanometer, I is the range of desired ammeter, Ig is equal to Nk, the current required for full-scale deflection in the galvanometer, where N is the total number of divisions in the galvanometer, K is the figure of merit of the galvanometer. Then, the length of the wire required for shunt can be calculated using the formula L is equal to pi r square S divided by rho, where rho is the resistivity of material of the wire. R is the radius of the wire, which can be measured using a screw gauge. Cut the resistance wire at a length of L plus 2 centimeters. Make 2 marks near the ends of the wire so that the distance between the marks is exactly L centimeter. The wire is now connected to the terminals of the galvanometer so that the marks are just outside the terminals of the galvanometer. The galvanometer with the shunt connected across its terminals is the converted ammeter of the desired range. Connections are made as shown in the circuit diagram. The galvanometer with shunt resistance is connected in series to a battery through an ammeter, key and rheostat. Insert the key. Adjust the rheostat and set the current reading L of the given ammeter at a particular value. The reading of the galvanometer Ig' is noted. Now, the current through the converted ammeter is calculated using the relation I' is equal to Ig' into G plus S divided by S. The error of the converted ammeter is calculated as I minus I'. Repeat the experiment by changing the rheostat resistance. A graph can be drawn with I minus I' along y-axis and I' along x-axis. This is called the correction graph. Thus, the converted ammeter is verified with an ammeter of the same range and the correction graph is obtained.